Okay, so for our first one here, multiplying 457 times 36. Again, we start on the bottom number with the last digit. So we're going to start with the 6. 6 times 7 is 42. Now we can't squeeze two digits down here, so we're going to keep the 2 and carry the 4. Then we got 6 times 5 is 30. You always multiply first. So that's 30. Then you add the 4 that was carried is 34. So 4 carry the 3. 6 times 4 is 24. Plus 3 is 27. So 7, we carry the 2, but there's no place to carry it, so just move it over. And then we've always been told before we can move over, we have to put a 0 down here. I do one more thing. I always put a line up here. That tells me that those digits that are below the line are carried from before. They're not new carries, so I don't get confused with those. So now I'm using the 3. 3 times 7 is 21. So 1, and I carry the 2. I put that above the line, so I know that that's new. 3 times 5 is 15. Plus 2 is 7. 17, so that's 7, carry the 1. 3 times 4 is 12, plus 1 is 13. So 3, and we carry the 1 over to the next digit. Combining, 2 and 0. 4 and 1 is 5. 7 and 7 is 14, so we carry the 1. 6 and 1, 16,452. How many of you got that? Okay, anybody have any questions on getting that? Now again, I realize a lot of you are going to punch these in the calculator. So if you're estimating this, well, that's about 500. That's about 40. Well, 5 times 4 is 20. We still got hundreds times tens is thousands, so 20,000. So you're expecting an answer around 20,000, 16,000 is in that ballpark. So you know that if your calculator spits out anything too far away from that, that you should double check. For our division, I wrote it in kind of a strange way there, but it's really just this. 483 divided by 23. So to do this, does 23 go into 4? Nope. So we'll leave that blank there. 23 into 48. Yes, it goes in there twice. So 8's the last digit I used. So I put the 2 above the 8. 2 times 23, 46. Subtract the 2. Bring down my 3. 23 goes into 23 once. And that's it. All done. So 483 divided by 23 is 21. Okay. So I realized we started out pretty slow last class. Today we're going to keep moving along pretty slow, but we're going to get into a topic that is often pretty tricky for students. We're going to talk about integers. Integers, we're talking about similar to the whole numbers, only we're going to throw in negatives. We're still not going to deal with any decimals or fractions. But if we're looking at our number line, our whole numbers are like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, those are part of our integers as well, but the integers also include the negatives. Negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, and so on. And to understand how integers work, we need to understand how numbers are represented on a number line. There are a couple of different ways of representing numbers. One is to just put a dot. Like if I wanted to represent the number 6, I'd just put a dot at 6. But that's more of a representational way of putting it down rather than an operating way of using it. So if we're going to be doing anything with it, the operational way of representing the number 6 is with something called a vector. Now a vector is just a really fancy word for an arrow. So all a vector is it's an arrow that starts at 0 and goes to that number. So 6 is over here. So it starts at 0 and goes to 6. So that's the graphical representation of the number 6, the value 6. Addition is defined to be just combining vectors. So let's say I have 6 plus 2. What that means is I take this vector for 6 that I just drew, make the vector for 2, and addition means I'm going to combine those. So I'm going to move this vector for 2 to the end of the 6. So those two vectors together now make one long vector that goes how far? 8. So 6 plus 2 is 8. Now again, you guys didn't need to draw that out to add 6 plus 2 because most of you have those addition facts memorized. But the reason I show you that is, now what if this problem becomes 6 plus a negative 2? Now the parentheses there are just to represent that that's a negative 2 and not minus 2, not subtract 2. So a negative 2 would be represented up here like that, going from 0 to negative 2. And if I move that vector to combine it with my 6, oops, that's not what I wanted. Get back here. Let's try that again. Move that vector to combine it with my 6, I end up with that. Now the two of them combined, they actually work against each other, and I end up with a total vector goes from 0 to 4. So 6 plus a negative 2 is 4. Now, I don't expect you're going to draw out a number line every time you work with negative numbers, but when I'm working with negative numbers, I actually do keep that number line in the back of my head. I'm looking at, okay, here's 0, positive 6 goes that way, negative 2 goes the other direction, and it's shorter. So that I know, this tells me two things. One, it tells me my answer is positive because I'm on the positive side of 0. And it tells me that the two lengths, the two vectors go in opposite directions. So the values are subtracted. The values work against each other instead of adding together. There's a concept called absolute value. When I talk about the length of the vectors, that's all absolute value is the length of the vector. Another way of defining absolute value, or another definition of absolute value, is distance from 0. So I have the negative 2 up here that I was working with. It has an absolute value. Its length is 2. The symbol for absolute value is just a double line like that. So the absolute value of negative 2 is what that's asking. That is 2. What would be the absolute value of positive 2? 2. Very good. So what we have here is we have two numbers, one positive and one negative, that will have the same absolute value because they're the same distance from 0, just opposite sides. So if I'm working with something like 9 plus a negative 13, which has a larger absolute value, the 9 or the negative 13? The negative 13 has a larger absolute value. It's a longer vector. So now when I go to do this, just a little sketch here, the 9 is positive, so it goes in the positive direction from 0. It's going to take me up to 9. The negative 13, it's negative, so it goes the opposite direction. And we just said it has a larger absolute value, so it has a longer vector. So it goes the opposite direction, and it's going to go past 0 because it's longer. So this picture tells me that my answer is negative, and it's still the difference in those lengths, the difference in the absolute values. What's the difference between 9 and 13? 4. So the answer to that is negative 4. If I have negative 7 plus 15, same type of thing. Here's 0. Negative 7 starts out going in the negative direction. Positive 15, does that go the same direction or the other direction? Other way. Longer or shorter? Longer, so it's going to go past 0. So this tells us that the answer is on the positive side, and because they go opposite directions, it's the difference between 7 and 15, which is 8. So it's a positive 8. So here we've got negative 4 plus negative 13. Here's 0. Negative 4 goes that way. Negative 13, same direction or opposite? Same. Since it goes the same direction, we really don't care if it's longer or shorter. They go the same direction. So this is telling us that our answer must be negative. We're definitely on the negative side of 0. And what do we do to the two values? Do we subtract them or do we add them? We're going to add them. 4 and 13 make 17. So it's a negative 17. So we might have negative 11 plus 9. So we start at 0. Negative 11 goes this way. 9, same direction or opposite? Opposite, shorter or longer? Shorter. So it's going to stay short of 0. So we're going to stay on the negative side. It's going to be a negative 2. Difference in the values is 2. So now with these smaller numbers, you probably could draw out the number line if you wanted to. But I'll use these even if I'm working with larger numbers, like 239 plus a negative 417. Here's my 0. 239 goes that way. It's a negative, so obviously this is going the opposite direction. Longer or shorter? Longer. So I'm going past 0. So I know my answer is negative. I might have to do a little bit of work here. It's the difference in values, so I'm going to subtract the 417. I'm going to subtract the 239 from it. So I borrow to get 8. I'm going to borrow here. 10 minus 3 is 7. 3 minus 1 is 2. So that is a negative 178. So in your notes, I want you guys to try a couple here. First one, negative 137 plus 94. Second one, 253 plus a negative 118. And the third one, 75 plus a negative 148. Try those three quick. I realize not all of you are done, but let's take a look and see how you did so far. So for the first one here, negative 137 goes to the negative direction. 94 is the same or the opposite? Opposite, shorter or longer? Shorter. So we're staying on the negative side. What do we get? Negative 43. Perfect. And then this one, 253 is going positive. Negative 118 is obviously opposite direction, shorter or longer? Shorter. So that one stays positive. How much? 135. Good. Positive 135. We really don't need the plus on the front of that, but that's fine. So then 75, negative 148, same or opposite? Opposite, longer or shorter? Longer. So we end up with negative 73. Good. So addition isn't so bad. Subtraction is where it gets complicated. So before we start talking about negatives, let's talk about the meaning of subtraction. We're all used to doing 5 minus 3. We've done subtraction since we started doing numbers. But what does it really mean to do 5 minus 3? Well, if I look at the number line, this would be 5. If we were to draw it out, we'd probably just go back 3 to get 2, right? We all know 5 minus 3 is 2. But if we look at that picture looks an awful lot like 5 plus a negative 3. Because that's what it really is. Subtraction is not an operation in itself. We mentioned on Monday that subtraction is just part of addition. So this operation, the subtraction symbol, when you see it, what it means is add the opposite. So it works with the number that comes after it. Minus 3 is saying add the opposite of 3. Well, the opposite of 3 is negative 3. So 5 minus 3 is saying take 5 plus a negative 3. So if we have something like 17 minus 4, that is saying take 17 plus a negative 4. Now in reality, for a problem like this where it's two positive numbers, it's easier for us to subtract because we've been doing subtraction for most of our lives. But if we throw in where one of those numbers isn't positive, like negative 13 minus 4, now it's a little more difficult. But if I rewrite that as a negative 13 plus the opposite of 4 is negative 4, now I can use my vectors. Because negative 13 goes this way, negative 4 goes the same way. So that's telling me that this has to be a negative, because we're on the negative side of 0. They both go in the same direction, so we're adding their magnitude. They're adding their absolute value. So 13 and 4 make 17. Where it gets tricky is if we have something like this. 7 minus a negative 5. So the first number never changes. That's always going to be the same. But the subtraction becomes addition. We are going to add the opposite of this number. So we're adding, so we've changed the subtraction to addition. What's the opposite of a negative 5? Positive 5. Some of you may have been told subtracting a negative is adding a positive, right? And that's why. It's exactly the definition of subtraction. So that is just 7 plus 5, or 12. So we might have negative 18 minus a negative 7. So does this become a positive 18? No. The first number never changes. That stays a negative 18. What's this going to become? Plus a positive 7, or plus 7. So now if we look at the vectors, we've got negative 18 and positive 7 goes the opposite direction and it's shorter. So we end up at negative still, but it's going to be negative 11. It's the difference in their lengths, the difference in their absolute values. So I'm going to have you guys try a couple. So the first one I'll do is negative 38 minus 21. We're going to do 45 minus a negative 19. Now do a negative 17 minus a negative 34. So try those three quick. Okay, so for the first one here, this becomes negative 38 plus a negative 21. So they're both going in the same direction. What'd you get? Negative 59. Very good. This one becomes 45 plus 19. Good. Well, we don't even need to draw out the vectors there. That's just going to be 64. This one is going to become, what happens to the negative 17? Nothing. It stays the same. Negative 17. This becomes plus 34. So from 0, we've got negative 17. Positive 34 is the opposite direction and longer, so we end up with positive 17, or just 17. Good. For multiplication, we talked a little bit last class about 5 times 3, and the fact that when we first learned to multiply, we were taught to do repeated addition. To figure out what 5 times 3 equals, we just did 3 5s added together to get 15. So if we think of it that way, as with a negative 5 times 3, well, it's pretty simple. That's just negative 5 plus negative 5 plus negative 5. 3 negative 5s added together is going to be negative 15. It's a little trickier when we look at 5 times a negative 3. By the way, one of the ways we would write that, since there's a parentheses there already, we don't have to put in the multiply. 5 and negative 3 in parentheses means multiplication. This is saying take negative 3 5s and add them together. That doesn't make much sense, does it? Well, with multiplication and addition, we can take those two numbers, as long as it's just multiplication or just addition, and we can change the order. So we can make this negative 3 times 5. So now that's saying take 5 negative 3s and add them together. That makes more sense. And what do we get if we add 5 negative 3s together? Well, it's still a negative 15. At some point, you were probably taught a negative times a positive is just a negative, right? Positive times a negative is just a negative. Somewhere along that process, you were taught if I take a negative times a negative, I get a positive. So negative 5 times negative 3 is positive 15. So we all know that's the right answer. The question becomes, why? Well, I cannot take negative 3 negative 5s and add them together. I can't add negative 5 to itself negative 3 times. I can't switch it around either. If I did negative 3 times negative 5, I can't take negative 3 and add it to itself negative 5 times, can I? Neither one of those makes sense. The definition of multiplication breaks down here. It doesn't make any sense. This happens in math quite a bit, where our basic definition of an operation doesn't work for specific examples. So what we do in those cases is we look for a pattern with the examples we can do and see what fits that pattern. So we had negative 5 times 3, which is a negative 15. So let's keep the negative 5, and we're going to change the 3. We're going to make it a 2. What's negative 5 times 2? Negative 10. If I did negative 5 times 1, we would get negative 5. So let's see if we can develop a pattern here. So for each of these, we started with negative 5. And here, we reduced this by 1 each time, didn't we? We went from 3 down to 2, went from 2 down to 1. What happened to our answer each time? It went up by 5, right? It went from negative 15 up to negative 10. From a negative 10 up to a negative 5. We added 5 to it each time, right? Yeah, the negatives trick you up. Makes it look like it's getting smaller, right? So if we go the next step, negative 5 times 0. What's anything times 0 have to be? 0. So let's check and see if that holds true. Well, we still started with negative 5. That's still true. Did we reduce this by 1? Yes, we did. Did this go up by 5? Yes, it did. So the pattern holds true. So if we keep going, we can assume that the pattern keeps going. So negative 5 times, what would this next number be? Negative 1 if we reduce it by 1 more. So this would have to go up by 5 to be positive 5. Negative 5 times negative 2 have to go up by 5 to be 10. Negative 5 times negative 3, again, have to go up by 5 to be 15. Mathematically speaking, multiplying two negatives does not work with the basic definition of multiplication. So we go by this pattern here that tells us that in order for the pattern to continue, two negatives must multiply to make a positive. So if I have 7 times negative 3, first of all, is the answer going to be positive or negative? Negative, and then of course 7 times 3 is 21. If I have negative 8 times 4, positive or negative? Negative, and 8 times 4 is 32. Very good. Negative 9 times a negative 5, positive or negative? Positive, and 5 times 9 or 9 times 5 is 45. Next, we want to take a peek at division. Now, we defined division a little bit last class as being repeated subtraction. I want to look at it, an alternative definition of division today. By again, we said it was a byproduct of multiplication, or multiplication in reverse. If I have 5 times 3, I get 15. So if I ask you, what is 15 divided by 3? I know that answer has to be 5. Because what this is asking us to do is to fill in the missing piece here. 15 divided by 3 is saying, I have a multiplication problem where the result is 15. I am multiplying a number by 3 to get 15. So it's asking what number times 3 equals 15? And that is 5. If I have 20 divided by 5 equals blank, that is asking what number times 5 equals 20? Well, that is what? 4. Very good. So 20 divided by 5 is 4. With that logic in mind, that process in mind, we can look at negative 12 divided by 6. What that's asking is what number times 6 equals a negative 12? Well, we know what number times 6 would be 12. 2, right? 2 times 6 is 12. Does that have to be a positive or a negative? Has to be a negative because the 12 is negative. Since the 6 is positive, it has to be a negative times a positive to make a negative. So that's a negative 2. If I have 18 divided by 3 or divided by a negative 3 equals blank, that's saying what number times negative 3 equals 18? Well, over here, what number times 3 would be 18? It would be 6, and it has to be a negative because the 18 is positive. And since the 3 is negative, we need another negative to multiply to be a positive. So this has to be a negative 6. Sorry. Or we might have a negative 24 divided by a negative 6 equals. So again, that's asking me what number times negative 6 equals negative 24. Well, does this have to be positive or negative? Positive, because I'm multiplying it by a negative and I'm getting a negative. And what number does it have to be? 4 times 6 makes 24. So that's be 4. So now when we look at this, the pattern ends up being the same pattern as we had for multiplication. When we were multiplying, a negative times a negative equals a positive. A negative times a positive equals negative. And a positive times a negative equals a negative. Well, if we look up here, a negative divided by a positive equals a negative. Positive divided by a negative equals a negative, right? And a negative divided by a negative equals positive. So when we're multiplying or dividing, what we see here is if they're both the same, either both negative or both positive, the answer is going to be positive, right? If there's one of each, one negative and one positive, no matter which one comes first, the answer is going to be negative when we multiply or divide. Now there is a button on your calculator that helps you with this. Depending on which calculator you have, a lot of you will actually have a button that should be down by your equal sign on the bottom end of the calculator. The equal sign should be right here. Right next to it, you have a button that looks like this for many of you. That's your negative key. If you have that button, it works just like writing out the number. If I have negative 5 plus 7, you would type in negative, then 5 plus 7, and it'll spit out 2. Some of you, however, have a key that looks slightly different. Might look like that. It's the plus negative key. It's actually called the swap sign key. If that's the key you have to do it backwards. To enter negative 5 plus 7, you'd have to enter the 5 and then hit that key to make it a negative. And then plus 7, and it equals. I encourage you to get familiar with your calculators. Make sure you know how they work with the negatives and get good at them. Negatives are the one thing that will cause mistakes throughout the whole semester, especially subtracting with the negatives. Even when we get into the algebraic numbers, I see a lot of it. Like 7 minus a negative 11 is going to be causing us problems 12 weeks from now. So make sure either you understand how to do those on your calculator so you can double check your work, or make sure you've got that down. Of course, we're going to change that from 7 minus negative 11 to 7 plus a positive 11, adding the opposite. Okay, so the next step then is to add in another set of operations. So far, all of our operations have come in pairs. We have addition and subtraction that come in a pair. We have multiplication and division that come in a pair. The reason they come in pairs like that is they're the same operation done in reverse. Subtraction will reverse addition. So if let's say I start out with a number. I'm going to start out with let's just start out with the number 7. If I add 4 to 7, I get 11. If I want to get from that 11 back to the 7, what do I have to do? Subtract 4. Here I see that adding 4 and subtracting 4 reverse each other. I get back to where I started. Well, the same over here. Let's take the 7 times 4. I would get 28. If I want to take that 28 and get back to 7, I would have to divide by 4. So here I see that multiplying by a number and dividing by the same number once again reverse each other. Well, our next operation we're going to look at is a power. That would be pronounced 8 to the power of 3. What does it mean? Not 8 times 3, but 8 3 times, right? 8 times 8 times 8, 3 times. So that's going to end up being, what, 512, I believe? How would you, I don't expect you to multiply that out by hand. How would you do that on the calculator? Well, again, depending on your calculator, you have one of two keys. Some of you have one that looks like this, y to the x or x to the y. Others have what's called the caret key. Looks like that. Most of your scientific calculators will have this key. Your graphing calculators will all have this key. And they both work exactly the same way. Type in the 8, press whichever one of those keys you have, and then the 3. It should spit out 512. How many of you have your calculators with you today? Most of you. Let's try a few, see how it works. We'll have you erase me. Let's do 5 to the power of 6. $15,625. Anybody not get that? Not know why? Three to the power of 5. 243. Negative 2 to the power of 10. 1,024. Anybody get negative 1,024? Okay. So why is your calculator doing that to you? Well, if you enter it like this, negative 2 to the power of 10. We're going to talk about order of operations next. We're going to do that tomorrow. Order of operations says a power happens before a negative. So what your calculator is doing 2 to the power of 10, which is 1,024, and then it's putting the negative on the front of it. So on many of your calculators, what you have to do is you actually have to put a negative number in parentheses to take it to a power. If I have, for example, negative 5 squared, that is negative 5 times negative 5. Well, we know that a negative times a negative must be positive. It better be positive 25. If you don't have those parentheses there, your calculator may try to tell you that's a negative 25. So be careful of that. Now, if I have negative 3, let's change that up. Let's do negative 7. To the power of 3, that's negative 7 times negative 7 times negative 7. I can only multiply two numbers at a time, so let's just work our way through. Negative 7 times negative 7 is a negative 49. I'm sorry, not negative 49, but positive 49. Right? Negative times negative is a positive. Times another negative 7. Well, a positive times a negative will be negative. 49 times 7 is 343. So here, I did get a negative result. Up here it was positive. Let's do negative 3 to the power of 4. That's negative 3 times negative 3 times negative 3 times negative 3. Negative 3 times negative 3 is what? Positive 9. Positive 9 times negative 3? Careful, negative 27, right? Positive times negative will be negative. It is 27. Now, a negative 27 times negative 3 is, negative times a negative will be positive. 27 times 3 is 81. So it's a positive 81. So what I want you to do is look at this for a second and ask yourself, I had 3 negative numbers to 3 different powers. 2 of them came out positive. 1 came out negative. How could I predict that these 2 would be positive and that one negative? Not that the power is positive, but the power is even and odd. There you go. You guys have it. This is an even power. And when there's an even power, we're going to be multiplying together an even number of those negative numbers. So they kind of pair up and they cancel out and become positive. This is an odd power, so when we multiply them out, there's going to be one negative left over, so our answer will be negative. So just a predictor, is this going to be positive or negative? Negative 2 to the power of 9. That will be negative. And 2 to the 9th is 512. Negative 3 to the power of 6. Positive or negative? Positive. Very good. And it will be 216. Okay. So now we've mentioned that those operations come in pairs. Addition, subtraction, multiplication, division. What is the opposite of a power? We kind of mentioned it. A root. Five squared is 25. The opposite of squared is a square root. So the square root of 25 must be 5. Because that square root is asking what number squared equals 25. Now I have to be careful. There is another possible answer here. 5 or negative 5. Because negative 5 squared also equals 25. What if I have 4 to the power of 3? What's that equal? 64. Very good. The opposite of a power of 3 is what we call a cubed root. Has the little 3 up here. This here, you could put a 2 here if you wanted to, but it's not necessary. It's just assumed. There's nothing written there that is a square root or a second root. So the cubed root of 64 is going to be, well, what number cubed equals 64? 4, right? Could it be also negative 4? Well, let's ask ourselves, is negative 4 to the power of 3 64? No, because it's an odd root, that's a negative 64. So this does not have, the odd roots do not have to worry about having it positive or negative. They're always going to be positive or negative. The consequence of that is, let's say I take the square root of a negative 36. What's the answer to that? If you guys look on your calculators, you find the square root key. Depending on your calculator, some of you have to hit the square root key first, then type in the negative 36. Others type in the negative 36 and hit square root. What does your calculator tell you? It says error. Why is that? Well, because the square root of negative 36 is asking us what number squared is going to give us negative 36. Now, what's the problem with that? It's an even root, so any number squared is going to be positive. There's absolutely nothing we can square that'll give us a negative result. However, if I do a third root, a cubed root of a negative 64, we said the third root of 64 is 4. That one's going to be negative 4. Because we saw that negative 4 to the power of 3 is a negative 64. So because our even powers are always going to give us positive answers, we cannot do an even root of a negative number. I cannot take a fourth root of a negative 512. It's not going to work because it's an even root. I can take a fifth root of negative 512 because it's an odd root. We are out of time, so we'll cut her off here for today. The first homework assignment, homework 1 in my math lab, is due for Monday. We do still have class tomorrow, but there won't be a new homework assignment. In fact, we still have to finish up some of the stuff for this homework assignment. Remember, when you go into my math lab, there's two ways to get to your homework assignment. One is, it should appear here in the dashboard, but if you have problems with that, just click on homework here and it'll take you to the list. And it'll even tell you this one is due January 30th. So that's the next one coming up. And go on through them. Like I said, if you have any questions, we'll take some time tomorrow if any questions come up. We've done most of the material for this. We have not done order of operations yet. So we'll do order of operations tomorrow, which will be part of the homework that's due on Monday as well. So you guys have a great day. We'll see you tomorrow.